multiple variables that we have to look at, many variables. So let's just start with the bean itself. There are 35 to 40 different varieties of beans, and they're grown in all different places around the world. So some of the main beans are Arabica. That's sort of the main type of bean. And then underneath Arabica, there are multiple types and grown in different regions. And they're kind of known for being grown in different regions. So some, examples of this, there's a Gesha bean, which is something that was grown in Ethiopia and is one of the most expensive beans that you can buy. So a lot of the beans are local to originally originated from Ethiopia and were transferred around the world. Another type of bean is a bourbon bean that the Dutch supposedly gave to the French. And that bean, there were 4 plants and they were transferred and have grown all over the world and are very popular in Brazil and Latin America. So lots of different types of beans. Each type of bean has a slightly different flavor, shape, size, and different qualities to it. So Robusto is a bean that's very robust to diseases and doesn't have problems with diseases. It doesn't taste as many of the different types of Robusta doesn't taste as good. So there are all these different types with the beans. There's another, for example, one bean, a coffee tree is grown within a mango forest, and so it has flavors of mango. So how it's grown, a lot of beans are grown on volcanic soil, and it tastes different that way too, with different minerals. So a lot of different variations in just the bean itself. And when you get to roasting the bean, things change, and we'll go into more detail about roasting in a second, but things change even more. So the key with espresso making is to have relatively fresh beans. If they're just been roasted, that might be too fresh, but a week or two after is when you've got that special time when the beans are the best. And so you want fresh beans as much as possible. The type of roasting, we'll go into this into a little bit more detail too, but light, medium, or dark. That's how long it cooks. Light roasting tends to bring out more of the fruity flavors, the original flavors of the bean. Dark roasting brings out more of the chocolatey flavors. And if it gets too dark, then it becomes more charcoal and bitter flavor. But so there's a fine line in even the dark type of roasting. And light roasting, you can get that chocolatey flavor as well. So different types of roasting and different types of beans roast better with different types of roasting, with specific types of roasting. Then when we go into grinding the beans, so once the beans are roasted, there are many different variables in how we grind them. So the finer the grind, the smaller the coffee grinds, the more that the water can dissolve the materials in that coffee ground. And so really fine coffee, you can dissolve it much faster. And so that's generally a good thing. But if we dissolve too much of it, then we get pull some of the bitter flavors. So we want to get just the good flavors. So there's a fine line between coarseness and fineness. The longer the water is in contact with the coffee grinds, the more coarse we'll have our grinds. So with espresso, we're making it very quickly. It's under pressure. We want a finer grind. If we're doing a pour over some sort of machine, it's going to be more coarse because the water is going to stay in contact with that coffee longer. So we grind based on the type of method we're brewing our coffee. The distribution of the grind, I'm going to go into this in great detail in a minute, but we want our distribution to be somewhat close to each other. If we've got a wide distribution, we're going to have some of the grinds be too fine and get over extracted, some be too coarse and get under extracted. So if we're trying to grind fine, we want most of the grind to be fine. We don't want a wide variation in that. There are different types of grinder and the way that it crushes the bean. So there's conical grinders, flat grinders, or even the blade grinders that are a little less expensive. That plays a role too. How fast the grinder is grinding it. If it grinds it really fast, it can bring out a lot more fine grind to it. And then also like the big restaurants will have a large bin on the top of beans. And if they're using those beans, they stay relatively fresh. They're filling that up almost daily with new beans. If you're doing it at home, if you've got a bin on the top, the beans could be sitting there for a week or more and get stale over time. So a lot of the home grinders are becoming single dose, where you pour out your beans from the bag itself so they can stay more fresh, and then you're grinding just that dose of beans rather than having a big bin on the top. And then the even finer details, like once you grind the coffee, it starts to oxidize and get stale. So from grind to brewing, you want that time to be as short as possible. And some restaurants will say less than 30 seconds. If we think about store-bought coffee that's already ground, it's becoming quite oxidized, just sitting in the bags for weeks on the shelves. So the simplest solution to make your coffee better is to grind it at home right before you make it. So that's, if I have one recommendation from this talk, is get a grinder and grind it as soon as possible right before you make it. Some other variables that we think about is just in espresso making specifically is extraction and how we extract the flavor from the coffee grinds. So we've got temperature. The hotter the temperature, the more we're going to extract. It dissolves things better when it's hot. But if it's too hot, we're also dissolving those bitter tastes. So we've got to find that right temperature for that. It's just the same as in tea making. If it's too hot, you'll get bitter tea versus, too low of temperature, you get weak tea. The pressure at the puck is important. The puck is where the coffee grinds are kind of together in the water. That's called the puck. The pressure, the more pressure we put on it, the more we extract. And kind of the traditional is 9 bars of pressure, and that extracts, that's the espresso extraction. The time under the pressure, as the more we put that pressure on there, the puck starts to dissolve, the coffee solids start to dissolve, and over time it starts to break apart. And it doesn't, the bitter flavors are starting to come out. So when we make an espresso, it's usually about 30 seconds or less. And if we have that pressure on it for too long, it starts to break apart. And again, the coffee becomes bitter. Some other things like pre-infusion, these are kind of newer techniques, just adding a little water to the puck, letting it sit so the things start to dissolve, and then putting pressure on it. So that's a pre-infusion type of process. So some other things that we will think about with our coffee, and when we think about the taste of our coffee, we'll talk about weak coffee versus strong coffee. And weak is watery, like it's maybe even like tea. It's a little empty flavor. You can taste the traces of coffee, but it's not very thick and rich. Strong coffee, on the other hand, is maybe too bitter. It's intense. It's not the flavor. It tastes like strong coffee. And maybe that is what some people are used to, that strong coffee flavor. But if we get it right, what we'll have is sort of in the middle. We'll have something that's luscious. I like that word, luscious. It's creamy. If you get a good espresso, it's almost like it's got milk in it because it's got the crema and the creaminess to it. And that will taste really rich. You'll get the flavors without it being bitter. We also think about just that extraction, and that's how much of the coffee is dissolved in the water. And so on the low end, we get that same sort of watery lack of flavor, just a taste of the coffee. The high end, we also get the bitter, the astringent type coffee. So again, in the middle is where we get the right amount of extraction. We can actually bring out a lot of sweetness to the beans. They have a lot of sweetness built in. And so if we extract correctly, we'll get a good sweet coffee. All right, so let's get into more of the details and even like roasting. So if you look at the shape of the bean, it's not a perfect sphere or square or anything. It's got ridges to it. And when we roast that, when we heat it up and roast it, it's hard to get that even. So uneven roasting is changing the flavor. So the outside could be really roasted, be really dark, and the inside could be under roasted or underdeveloped. And when we have that, it's not consistent. And what we're looking for in the whole process of espresso making is consistency. So the more that the roaster knows how to get the bean roasted equally as much as possible, the better the coffee is going to taste. So we want it to be, if we're light roasting, medium roasting, or dark roasting, we want it to be even for the whole bean. So that's going to be an important part too. This is out of our hands. This is really up to the roaster to take care of this. So when we're thinking about extraction, we're going to think about coffee particle size. And I mentioned this before, fine coffee versus coarse. And if we think about the water flowing through the coffee grinds, the finer it is, the more surface area the water is going to touch, the more it can extract. So if we think of salt and we put some salt in water, if we've got thick Himalayan sea salt that are chunks, those aren't going to dissolve completely. But if we have very fine salts, grains, they dissolve because water can touch a lot of that surface area and dissolve it completely. So we want that, how much time the water is going to touch the coffee, we're going to make our grinds equal to that or relative to that. So we don't over extract or under extract. Here is the tricky part of grinding coffee. And when we think of the distribution of grinds, when I have this picture here, we're thinking all of the grinds are exactly the same. But the way a coffee bean is ground, it's either crushing or cutting the grind up, and we get a distribution that's not a unimodal distribution. We get distributions that look a little bit different, where we might have, like for example, the green peak on the right side, that's pretty unimodal. It's mostly in that one peak. But if you look at the red on that right side, we have almost two peaks, and there's a smaller peak, and that's in the finer direction, and then we have a larger peak in the coarser direction. And why that peak happens in that fine is that the coffee is being crushed, and sometimes when it gets crushed, it explodes, and that explosion causes there to be some fine grind. So even though we've got the setting to a certain distance between that, and we'd like it all to be in this one range, the crushing process itself breaks it into smaller bits, and those fines make a little distribution of its own. If you look on the left side, this is actual data from different grinders, and we see that on the left-hand side of that distribution, we see that little peak of fines. And those fines can cause us problems, because if we're making the coffee thinking about the peak, those fines are going to get over extracted. So we're trying to figure out as unimodal of a direction of fines as possible. And this is just a little diagram of just what coffee would look like if we think about that distribution. We've got these larger particles, and the water's trying to dissolve these larger particles. But within those larger particles, we have a bunch of little small ones. And those small ones can move around and migrate. So the purple ones are migrating. Sometimes they migrate to the bottom of that filter and actually block holes in the filter and block the flow of coffee, which can be problematic. Sometimes they stay attached to the larger grinds. But if we think about that, that's all happening within the 30 seconds of espresso making, that these different things are happening. So there's a lot of variables involved. And then finally, we have, this is what espresso making should probably look like. It's a pretty good flow coming out. You see that there's darker colors, and those are the parts that are just getting extracted. And then the creamy colors are, towards the end of the extraction. This is pretty even. We're seeing a nice picture here, and this would be really good, creamy, full espresso making.